Okay, welcome to Philly.net monthly meeting. This is the May edition of 2018, and I'm Bill Wolf, the leader of Philly.net, and we have an interesting and different presentation tonight. We're going to do an entire evening on blockchain, and this is an exciting new technology. A lot of people are interested in this, so hopefully you get some good value out of this. For the first hour, Mahesh Shan is going to go over the basics, teach you a little of the fundamentals, the concepts behind blockchain, and then Henry He from Princeton area is going to actually go into .NET coding examples. So you get a little mix of both tonight. This is Philly.net meeting, and of course, the main way that you find us is to use meetup.com, which I have on the screen. So in the, if you go to meetup.com, you see the current meeting, and the best thing to do is to click, you see where it says see all? You should click that once in a while. And I've been trying to keep the meetings up to date, so you'll see that tonight is blockchain for .NET developers. And I have this clever new technique here where I put the speaker's pictures, and if there's a sponsor, we put the sponsor too. Woohoo! You two are now buds forever. Okay, in 2 weeks, we have our popular hands-on lab series, and that right now we're going through a 6-month agenda that has to do with ASP.NET Core, and using .NET Core 2.x. And we've had 2 meetings on that so far. And in the first Wednesday in June, Rob Kaiser, with the help of Chris Gomez, they're going to go into Web API and also how to use this thing called middleware. Middleware is a way to add extra coding functionality to your website. And you should make sure you see that. By the way, there are 100 people already signed up, and if, depending on who you're logged in, oops, my mistake. Depending on who you're logged in as, you can actually see how many are on the waiting list. That one is pretty popular, so that one's already pretty well full. Then, very popular, once a year we have a special meeting where we ask members to bring in their children. And usually this would be children ages 7 or 8 up to like 18. They have to be accompanied by an adult. And we have presentations by kids for kids. So Chris, could you grab the microphone and tell us what's in store that night?
Yeah, so this year we've got, we're going to use this room, we're going to divide it in 2. And for younger kids, we have Ben Bateman, who's the son of Anna Bateman, a speaker in this community, will be presenting and teaching Scratch programming. So you'd bring your own laptops, they load up Scratch and use them to make simple games and animations. And we are also trying to get our hands on and see if maybe we can do some microcontroller stuff, but that's to be determined. And then in the other room, for maybe more of a middle school age, and this is really at your discretion. If you bring somebody, they're going to learn to build their first websites using very simple tools. We believe it's going to be an online browser-based tool, but that's at the discretion of Justin Michelotti, the presenter. Some of you may know Steve Michelotti, often speaks here in our community. He and his son really kicked off Kids Can Code Night for us, and they are coming back, and he's going to run that room. So the signups here are for primarily so that we can reserve seats for how many students are going to be here. So we've got to make sure, we know that we're going to have space for them, and it's definitely bring your devices.
Yeah, we're going to have special refreshments that night, probably like an ice cream and cake social, anything to get the kids really round up before they go home. So. We don't get ice cream. Are you you're practicing that for when you get to the retirement home, or?
Already there.
Okay. All right. Jumping into early July, we're going to do ASP.NET Core Signal R. Signal R is technology that allows you to build sort of real-time communication where the server actually talks to the client. And they've just announced at Build Conference that they're going to release Signal R as an Azure service. So it's going to be very, very reliable and redundant. So Chris will show you how to work with that. And then we'll be sending out soon, if any of you want to give a short talk, we do this once a year. We do 10, 15-minute sessions. And people usually have a good time with this. It's a little lighter. And then a bunch of speakers come out and show you, their favorite tip or technique. So that's going to be in July. And then in August, in the ASP.NET thing, there's new technology that you really want to learn. It's called Blazor. And we are going to do a hands-on lab with that and show you how to run C# inside your browser. Cool stuff. Now, in addition to this, we also have the old Philly.net website. My guess is it doesn't get used much anymore. This is going to be updated sometime this summer. But this is where the best thing for this is to see the code camp information, and that's we've used this to run our code camps over the years. So how many went to code camp this year? How many of you realize that there won't be another one this year? Okay, next code camp will be probably next March. Okay, but I will make a shameful or shameless pitch here. Part of the reason that we're not having a code camp is Bill is busy doing this. So there is a new conference that I'm going to be running at Villanova. And if you have a chance, take a look at this. The list of speakers is absolutely awesome. We're actually bringing speakers in from all around the world to speak here. So think of it, it's sort of like a code camp, but like maybe a couple times the size and with a lot more interesting presentations. So at this point in time, any questions on club? Yes, sir. The wireless password is written all the way over here, which is rude. What we might do is push that to the middle so you can read it on your side. Good of you to point that out. And as soon as you get that, at this point, I'm going to ask Mahesh to come up, and he's going to start his presentation on blockchain.
I'm all set. There's too many things going on here. I'm first time here on this kind of setup. I don't know which one to focus on. You good, Chris? All right, let's start with it. Jumpstart blockchain. I can really see people. All right, here we go. How many of you have heard of blockchain here? Let's start with that. All right, everybody? Perfect. So how many of you heard of Bitcoin? Sure, everybody? How many of you have Bitcoin? Owns? Anybody? 3? Okay. All right. Well, so we today's talk is all about coding, blockchain coding. We're not going to talk about Bitcoin. We're not going to talk about cryptocurrency. And the point here is there's 2 parts to this session. First one is basic concepts. When we talk about blockchain, more and more we read online, it's just written by marketing people, and it's very confusing. So first thing we're going to talk about basic concept, what blockchain is all about. Let me first go through this. Let's see if I can get this right. There you go. So in this session today, we will talk about what this blockchain is all about, basic concepts in blockchain, and why is blockchain so popular these days, like in recent year or two, and what kind of apps we can build using blockchain. And in the end, Henry is going to show us a real working coding demo. So I'm the guy who just come and talk. He's the one who actually writes the code. So I think it should be a good combination. And then in the end, we will have some Q&A. Make sense? All right, let's get started. So before I start there, my name is Mahesh Chan. I run a company called Mindcracker Inc. It's a small consulting firm. It's just a couple of people, nothing major. But I run a website called C# Corner. I don't know if you guys know C# Corner, but it's a community for C# developers. But now almost every developer is there. We have 3 million members on this, all programmers, all software guys. And last month we had 6.5 million visitors in a month. That was biggest we have ever had. I'm also a Microsoft regional director. That sounds like a big title, but it's really what I really do is if you have any problems which you can't find right guide within Microsoft, I'm the bridge between you guys. So if you're running into this big problem, you can get help. If you reach out to me, I think I can find the right guy in Microsoft to talk to you and help you out. All right, so let's get started. So what is blockchain? Blockchain is Bitcoin. So first thing, any article, any book, anything you read online or offline, if anybody talks about Bitcoin, just run from that room. Just get out from there, because that's the last thing you want to do is talk about Bitcoin when talk about blockchain. I'm sure most of you guys are programmers, right? Almost everybody is. Anybody who's not programmer here? Okay, everybody, almost everybody is. And everybody knows a website is, right? Let's start with that, what a website is. And I'm going to simplify this so clear. So I'm going to really simplify. So by the time you leave this room tonight, you will know exactly what blockchain is, how it looks like, how you feel it, how if you go and blockchain is walking on the road, you will know this is blockchain. That's how much I'm going to simplify it. So if you know what a website is, let's talk about the website. When you think of a website, usually there are some web pages. There is a URL, right? You go to a URL. You type a URL in a browser. There's a web page is being served on the browser, right? Then probably there is somewhere there's a database store. The data is coming from that database. There's a web server running also. It's probably IIS or one of those web servers. So all these combined, there's probably API, there's probably service. If you combine all this, there's a database, there's a hardware running somewhere server, on server there's an operating system running, there's a web server running, and there's a web page being served within the browser. So all this combined, think of this as a complete website. When you think of a website, that's what complete website is, from end user to the delivery. So when you talk about blockchain, if you compare to that, what is that look like? What does the blockchain look like? It's a database. So when you think of blockchain, it has one element, it's basically database. So there is a data stored somewhere. But data only that has transactions. So if there is you have a database and it doesn't have any transactions, you probably don't need a blockchain for that. Blockchain must have a database with transactions. Transactions usually involve two parties. It's one to other. So that's how you have to think if you're thinking of blockchain, that there's definitely a database and there's definitely transaction-based database. We're clear here? It's a shared. So every blockchain, this database is shared on a peer-to-peer network. It's not a web server. In web server case of think of a website, there's a server, database probably stored on the server. It's being served to all the users from one server or a couple of multiple servers. If it's if it's shared on hosted on multiple machines, right? In case of blockchain, it's peer-to-peer. There's no one server here. What does that mean is in a blockchain, more than one parties are involved. So you have this database. Imagine that this is a blockchain. In blockchain, every person who's involved in the blockchain is called a node. Imagine this is a blockchain, this room is a blockchain. Everybody who's involved in this room, each of you you are a node. And all of you have the exact copy of the same database. Everybody has a replication of that database. Same transactions, same record. Is that clear so far? So blockchain is a database. It's distributed on a peer-to-peer network. It's not a server like how web server. It basically everybody has same copy of the data, and it's distributed. Obviously, we cover a little bit. It's a distributed means in the network every computer has the copy of the database, and it also has obviously, and it's secure. So this is a very important part of this blockchain is security. Before any transaction is being added to the database, it gets secure. It gets encrypted using cryptographic different keys, private, public keys. And in the end of the session, you will see how we do in the code. So let's recap this quick. If you think of blockchain is a combination of some code and a database. It's a store in a peer-to-peer network. Everybody has a duplicate, same copy of the data and also the code, and then it's secure. So now that's one of the reasons makes it important today is that it's secure. It's basically if somebody goes and hacked into the database, guess what they're going to find? It's all encrypted. It's all hashed. Well, but that's so simple, right? But how do you simplify it? How do you even simplify more? Like so far we talked about distributed database, we talked about the cryptography, we talked about the peer-to-peer network. But if you have to define, how would you define it? So it's a code with a distributed database that is cryptographically secure and shared. So this could be one of the definitions if somebody goes and talks to you. And transactions are approved using a democratic system. Now, what does that mean? This is a new term here, right here. What does that mean is if a new transaction comes, let's say somebody says, okay, I want to pay you $3. It's a transaction because I'm trying to pay you. So there are definitely two parties involved here, right? There's two parties involved. And this transaction has to store on a blockchain. Everybody on the system has to approve this before it gets added to the blockchain. That's how blockchain works. That's why it's secure. That's because it's a voting system. In the case of a website or the systems we have now today, they don't use blockchain. They are just if one guy goes and add a record, or DBA goes in the back end in the database, go mess things up, or somebody goes delete a record. Sure, there may be an audit for that, but one guy can go and change anything. But in case of a blockchain, if somebody goes and add a transaction, it has to be approved by everybody who's involved. So imagine that if new transaction comes into this room, and this is blockchain, and all of you are node, all of you have to approve that. So that's why it makes it valuable. That blockchain systems that's why they are very secure. That's why most of these transactions, especially like Bitcoin, and even though they're public, but they're secure still. The reason is because you can just go and tamper those records. Now, bigger the network, more secure your blockchain is. And I'm sure you already know why now, right? Because more people has to approve that. So if you have a blockchain and it's only one person, two people are using it, sure, two people can use it, a blockchain, because now there are only two nodes, but it's not that secure because there's only two people have to approve it. But in case of, say, Bitcoin, I know I'm not supposed to talk about Bitcoin, but Bitcoin is the largest blockchain out there. That's more secure because they have more nodes than anybody else. So is that clear, everybody, what blockchain is now? Any questions so far? Because goal is to make sure that it's clear. If everybody has questions still, we can answer those. But that's the whole idea, is make sure everybody understand what blockchain is. Yes. Yes, of course, of course. Imagine that if I'm a blockchain node and all I care is about my transactions, guess what? You still have to download the entire project on your machine. So yes, they're slow, and we'll talk about these problems later too. So it's a slow because Bitcoin, one transaction on Bitcoin blockchain takes about they take 7 minutes now. So imagine you want to pay somebody, it's going to take you 7 minutes to get that approved by all the nodes. So larger the network, yes. So there's a lot of data being replicated.
So it's faster than going to Walmart.
Yes, it's definitely faster than going to Walmart. But then there are three kinds of blockchains now. This was the first idea. There's an idea is there's a public blockchain called permissionless. Public means anybody can join that blockchain anytime. Obviously, you have to follow the rules. So tomorrow, if you go home, say, I want to be a node on blockchain, Bitcoin blockchain, you can be that. You just have to download the code. It's an open source project. You run on your machine, and out of a sudden, you are one of the nodes. That's public. That's called permissionless. There's anybody can go download. Then there's a private permissionless, and there's a permission. But in the case of permissions, they are open source project. Let's say I create a new project and say this is a blockchain. Anybody can go and download it, but before they use it, I have to approve them. So I have to verify them. So out of sudden, I can now restrict my network to limited people. Now imagine you are in a banking system. Let's say you are working in a bank, TD Bank, for example. Now they're not going to make their blockchain public to everybody, right? But they can restrict their blockchain within organizations, so they can only have few hundred, maybe 200-300 servers or machines or laptops using that blockchain. So that's a really private blockchain because it doesn't have access to the, public doesn't have access to that. So we can go in more details. Yes. What do we mean voting, right? All right. This is a perfect example. I can simplify you. So I'm from India, and so I lived in India for 20 years. When I was in India, when you get married, basically there is a social marriage. There was no record of like a signature, or there was no certificate. Everybody goes in a village, 200, 300, 500 people participate, and everybody approves that you're married, right? Now imagine everybody knows that you're married, so there is a social proof of that. Now imagine there's a conflict happens, there fight happens, and you say, you know what, I want to get divorced. Well, guess what? All those 500 people are going to come tell you, no, you can't do that. It's a bad thing. No, it's bad for this. So there is a social pressure there. So same concept apply there, that if there's a voting system, when new transaction comes in, they all have to verify it. And how do we verify it? You will learn later. Henry is going to show you. That's why we need a cryptography also. That's where it plays major role, how it works actually in the code. But thing is that when new transaction comes, everybody has to verify it, and the verification process through hashing algorithm. And you can see in sample, but every hash has to match. If they don't match, means something wrong with this transaction. So that's what I mean by voting system. And 51% vote has to be, 51% nodes have to approve that to get added to the blockchain. That's the minimum requirement. So let's look at about some of the blockchain building blocks. And these are some of the terms when you think about reading about blockchain, when you talk about blockchain, when you write code, these are some of the terms you will use from time to time. And I'm going to simplify them as much as I can. And then in the end, you'll also see how to really see in the action in the code. Cryptography and hashing. Does everybody know hash algorithm, hashing? Okay, I don't need to explain hashing. Basically, you have any data you apply, say 256 hash, everything convert to 256 characters, right? That's a good. So a block is the fundamental element of a blockchain. And blockchain, you can think of this as a data structure. And how does it look like in code? You will see. Think of this as a structure. You know how you write a structure or a class. You can write a class. Class is a block. The block has a number, block number, obviously. Every block has a block number. Then it has a hash of current block. Then it has some data. Data is the transaction which you're really trying to, pass through the process, the transaction. And what else it has? It has nouns and all that. We can go in more details. Yeah, but block is the basic fundamental element of a blockchain. So when you create think of this like if you have a database, right? Let's think of this. You have a customer database, right? You have a customer database. What does a transaction look like? Probably it's a customer that has name, but address, some record, how much money being paid, things like that, right? So that's one row in a database, right? So block is kind of one record there in a blockchain. You create the block, but it has more than just the data. It has hash, it has nums, it has a block number. So those are just extra. So that's a fundamental element of blockchain. It's a structure. Blockchain, it's a combination of blocks, is a blockchain. What the blockchain is differentiated is that the current block has a hash of previous block. The current block has a hash of the previous block, right? And the next block has a hash of current block. So that's how you know that these are valid blocks, because there's a reference. You guys know you have done pointers, right? Most of pointers, yes. List, linked list and all that. So kind of same concept works here. The only difference is that it has to make sure to a new block to be added to the blockchain. It has to make sure the hash of previous block and matching with the current block. So there's a reference there. So it's exactly, if you have done linked list, you have done pointers in C++, this is how exactly it works. And there is Genesis block. Genesis block is the first block in a blockchain. That's a little different. And how it's different, Henry will talk. It just doesn't have reference to the previous block because there's no previous block. And there is a consensus algorithm, and that's where we were talking about the voting system, right? When you talk about the voting system, every blockchain has to have a voting system, a consensus algorithm. And so far, there are two major algorithms being used in major blockchains, right? One is called proof of work, and other one is called proof of stake. And these are very important fundamental parts of understanding when you're writing your own blockchain. In a proof of work, we just talked about everybody has to agree on the transaction, right? So now you just had a question that, oh, it's going to take so much time that all of these thousands of nodes has to do all the work. And new transaction comes, they have to calculate and they have to match the hash. So some innovative people came up with another algorithm. It's called proof of stake. And proof of stake, what they do is they assign some validators. They're like, you know what, rather than everybody in this room approves the new transaction, we will say, Bill, it looks like you are authority. Henry, you are authority. So we'll pick few guys, and you guys will pick, and you just approve that transaction. And this will change. The role changes depends on your value, your size of your network, how much work you have done in the blockchain. So that's how it works, right? So that's so when you think of this, when you read a blockchain, you're buying a Bitcoin or any coin, you say it's based on proof of work. You need to know, okay, this is doing so much transaction. There's so much extra overhead happening here. While if it's a proof of stake, it's probably smaller work being done there. And then we also going to see all this in action too in the coding. That's a good part, right? So I want to build the foundation here, so in your head you understand a little bit idea, then you say, oh, this is how it works, right? That's the whole idea. And there is a mining and miners, right? So to approve those transactions, all the nodes, they are working and verifying those are called miners, and the process called mining. So you may heard of something that, oh, this guy's mining Bitcoin, this guy's mining cryptocurrency, right? So those are some guys sitting with the computers and downloading the whole project with the whole database and processing records, and any transaction come approving those transactions. So that's what it is when you hear of those, okay, oh, he's mining cryptocurrency, right? That's what exactly they're doing. They're downloading the open source project and running that project and on their machine. Questions? Yes. Yes, good question. So why do you want to be a miner? Why do you want to run? So right. So in cryptocurrency world, what happens is for mining, everybody gets a little reward. That's basically you get a token. If it's you are mining Bitcoin, you'll get a piece of Bitcoin. Larger the network, less you will get. Smaller the network, more you get. So in the beginning, when Bitcoin started, people were getting a lot of Bitcoins because there were only few nodes were mining, approving the process. Make sense? So yeah, you get money, you get basically whatever you're mining, you get piece of that. And every reward is different. Every blockchain has a different algorithm, how much you get paid, who you get paid, how, all those processes, right? In case of example of, if you go to this proof of stake, so in case of proof of work, right? Let's talk about proof of work. If everybody is trying to approve, whoever finds out the solution before anybody else gets the reward. Only one guy gets the reward. Here's the difference. That means if 100 nodes are processing same transaction, and whoever the powerful machine, most fastest computer, they find the solution first, they win it. They get the reward. 99%, you just wasted your energy. So there's so much energy being wasted, and also especially in these cryptocurrencies. I don't know if you heard of that. Somebody wrote an article that in the whole cryptocurrency, the amount of energy they take is more than whole Canada spend in a day or month or something. So because it's like machines running, and these machines are not like regular machines, they are powerful machines. They're designed for crypto mining. Right, but in proof of stake, you assign 3 people. Out of 3 people, one guy finds out and he gets the reward. So it's like it's much efficient algorithm for resource consumption point of view. And there's more newer approaches coming as well, but they are not as popular as these two. More questions? We good here? And there's a network protocol involved, obviously, because that's how these nodes connect and talk to each other. Without that, it won't be possible. It's a secure network protocol, and there's different networks using different protocols. If you have done any, RPC, you probably know how these, nodes and computers talk to each other. You just there's protocol with port open, and when you install the project, they will check that once you project with blockchain and install on a machine, they'll make sure it's open and talk to each other. So this is basically a fundamental building elements of a blockchain. Once you know these, you at least get an idea that if I need to build my own blockchain, which is basically you're building a software with the data, right? Database in the backend. That's what it is. Blockchain is nothing. It's not a big deal. It's just code with some data. Okay, how data is stored? It could be in a text file. It could be a database. It could be in a whatever the format you want to store. How is the code written? You can write in anything. You can write in C, C++, Java, whatever you feel like, as long as it follows those 3 or 4 rules in the beginning. We talked about what a blockchain is. As long as you understand this fundamental, you can just go home and write your own blockchain right now. Any questions here? Everybody clear? It could be any type. You can create your own data type. You can have objects. You can have your Excel. You can have text, anything you want. There's no rule for any data you can put in there. No, there's no limitation on size. Obviously, bigger size will take more. You can put anything in it. There's something called smart contracts. People are putting big documents in those. So for those, there is special databases. There's a block database. If you have a bigger files, you can use the big block, or there's different databases for that. But there's no limit. You can use whichever you want. What do we use blockchain for? Yeah. What's the purpose? So that's a good question, right? Why do I need a blockchain, right? So I think there's one slide. Yeah. Why blockchain now? Yeah, it's coming. Right, it's coming. There's a slide just on that. There's a reason. Yeah. So why is blockchain very important, so important or popular now these days? Well, there's multiple things happened recently in the past 2 years. And one of the reasons was the success of cryptocurrency. I'm sure everybody heard of that. Blockchain when Bitcoin went from few cents to $10,000 to $20,000. What is this all about? It's just a bunch of, this is not a real money. How come it's that much, right? People who invested like a few $100s in it, now they are multi-millionaires. So that's one of the reasons. Everybody's that's more like a hype side to it. That, oh, I want to learn blockchain because I can make money. So people are misrelating these two things, right? Blockchain has nothing to do with cryptocurrency. Blockchain is a software, how you build a software in a stored database. It's a technology. It's like a website. You think of a website, anybody can go build a website. It has nothing to do with how much money PayPal makes, right? So people are basically relating these two wrong things. So that's a kind of hype. That's why blockchain is, because when you think of blockchain, people think, oh, it's a Bitcoin, it's a cryptocurrency. So that's why I said first thing, when you want to learn blockchain, you need to get the whole cryptocurrency out of your system. Otherwise, your fundamentals will be all gone. It brings peer-to-peer trusted systems, right? So what was happening is, let's open these there's four things, right? So cyber crimes have written so much these days. Everybody's worried that all these banks, all the big institutions, they're worried that their data is being stolen. How do you secure that? And one of the way to secure is that blockchain. Because remember, before any transaction is being added to the database, it's being securely encrypted, right? Do you really need blockchain for that? Probably not. But imagine that if you are using a blockchain and somebody hacks into one of the nodes, right? One of the servers, let's say, and they go and change the database. Guess what? First of all, they can't read it. They have to, basically, because it's all encrypted. The whole block is encrypted. The whole object is encrypted from the base, right? And let's say they somehow go and change it. To change and save it to the whole system, it has to be approved by all those 99 people, right? So you can just go and change anything. You can tamper it. So remember, you hear all these stories that, oh, from this bank, this much money got stolen. When you think of that, what happened was really somebody transferred money from one account to other account. Somebody wrote, okay, from this account, this is the number, move this money from here to here. In case of blockchain, that's not possible. We just saw that, Target got hacked, and they're like 200 million, customers' data got stolen, right? In case if they were based on blockchain, that they could do anything with it. Go ahead and steal one node. You can do nothing about it. Remember Equifax, everybody, like, data got stolen. So all these problems happening. There are a lot of companies, the data says that 6 out of 10 big corporations are thinking to implement blockchain in the next year or two because of these problems. Because everybody's afraid that if our data it's probably already stolen, right? They don't even know that, right? We know that if Equifax is saying that it's 200 million, I bet it's everybody's data is stolen. We got anybody on Twitter here, right? Twitter? Yeah? We got message other day, right? That, oh, your password was stored in a log file, plain text file, but nobody read it. But we just found out. Well, if nobody read it, how you found out that, right? And why stored in log files? Because imagine all these big banks, big corporations, they have this data. This software was written like 10 years ago. Database was implemented 20 years ago. They have not upgraded those. But hackers are more smarter these days because everybody's connected to the internet. That wasn't happening 20 years ago. So that's the big challenge as an industry-wide we have, is that everybody's connected, and these guys, network or database guys, this were done way before and they're not upgraded. So they think that next wave of this software and data, if it's built on blockchain, it's going to be more secure. That's why sometimes you hear this term that blockchain is next internet. Doesn't mean that it's going to replace internet. It means that new software is being built based on blockchain is more secure, and it's going to be hard for hackers to steal data, steal and hack. That's why it's being more popular. And then another last point is community driven. So all these blockchains are community driven, means, remember, we just saw a voting system. Not only that, most of these public blockchains are developed by open source community. It's not managed by one company or one person where if I'm I'm this architect, you know what, my way is the only right way. Everybody has to write code the way I like. That's how we are. Some of them are stubborn developers, right? They don't know that, okay, they don't even want to learn there's a newer way to do things. But once you say community driven, everybody votes, everybody say, no, you're doing it wrong. And once 51% says that you're wrong, you still get a better solution out of that. So when the software is being built by community, usually chances are it's probably better code, it's probably better database, it's probably better architecture. So this is all better probably. Because now there's no one guy making the rules. Same thing with the data store, right? It's a bank manages your data today, right? So the bank decides, let's increase, interest rate, let's increase 2% more today because we need few more millions, right? Guess what? You get a letter. Oh, now we are increasing your rate from 13 to 17. There's nothing you can do about it. In a world of blockchain, it can't happen. So that's why it's more popular. That's why it's growing. That's why it's changing the way we think systems. It's changing the way we build systems. What languages you can use, as I said earlier, you can pretty much use any language, any choice you want. All you're doing is writing is code, you're storing data, and how this whole being distributed among the network. Once you know that, you can write in any language, C, C++, Java, JavaScript. Some of the most popular are Java, JavaScript is popular, C++ is very popular. Some projects are on C#. Solidity is designed for smart contracts. Smart contracts is another term in blockchain, which Henry will talk more about it. And that's very popular, that's very useful. And then these are some of the languages. So doesn't matter what kind of programmer you are. You can write in any language you want. It's pretty much open. You can store in any kind of database. So look at some of these numbers. So as I said, already mentioned that 6 out of 10 major corporations are looking to hire blockchain developers. So either they are building their own in-house, or they are looking outside, or they are looking at public open blockchain projects. There are not enough developers, and they are getting paid very high these days. And
They only get paid in cryptocurrency.
yes, if you want to, anybody knows, have questions about ICOs, initial coin offering? ICOs are simply like IPOs. A lot of companies are doing their own ICOs to raise money. If you want to do ICOs, it's probably good for you to start blockchain project. Only blockchain projects can do ICOs. The reason for that is ICOs are crowdfunding, and crowd only believes if you are building system based on blockchain. Remember, then they can vote, they can decide, they can also basically participate in those. I think that's about it. Any questions here? What we can do is let Henry come in, and then Henry is going to show you the real magic, and then we can do some more Q&A in the end if there's more time. Thank you.
Put this first. Can you hear me? Okay, good. So Mahesh gave you an overview about the blockchain. I'm going to show you something in action. My name is Henry He. I'm a .NET developer. I have been doing development for about 20 years, primarily on Microsoft technology. About 3 years ago, one of my friends told me about Bitcoin, Ethereum. So I spent a little bit of time looking into it and try to figure out why that. But I was confused, completely confused, because at that moment,
there are not much information for you to learn. Until last year, Bitcoin become very, very hot, very, very popular. Then I go back to learn that blockchain, Bitcoin, and related technology again. And I got much more understanding on that. At my company, I built a club, a blockchain club, because I want to push for the blockchain-related innovation. I also built a team, participate in the blockchain hackathon. We won the second place. So we did a lot of blockchain-related project and work. Before I start my presentation, I want to ask you guys, I believe most of you are .NET developers, right? Okay, that's good, because I'm going to show you the code in .NET. And Mahesh talked about blockchain. Do you understand? Good. What is blockchain? That's good. Let me show you my definition. A blockchain is a chain of blocks. Simple, right? Yeah, I'm going to that. Yeah. So this is my agenda. I'm going to give you a demo on basic blockchain. Then I'm going to move to the proof of work. That means I want to add something on top of this basic blockchain. Then I'm going to add a transaction and a reward. And I also want to make this become a distributed system. At the end, I'm going to show you a real-world blockchain-based application. Before I give you the code, I want to talk about the data structure. Because blockchain is basically a chain of blocks. So you can see I have four blocks here. I have block 0, 1, 2, 3. The first block is a Genesis block. And the first block doesn't have previous hash. It has previous hash field, but it doesn't have value because there is no previous one. Then you have the generic block, block 1, 2, 3. So I'm going to build a data structure like this.
Must you do this on average?
Yeah, I was thinking about that. That's a good question. But I think it's good for everybody to look at this Visual Studio. So I will use Visual Studio 2017 to start the application. I will start very simple .NET Core console application. I will call it it's just called P blockchain. Let me simplify. P blockchain. So switch back to here. I want to show you the okay. Like I said, I need to have a data structure that have 4 blocks, right? So I need to have a class called block. Let me add a class. Oh.
Oh, you can make it small.
Sorry about that. Let me make this bigger. The simplest way.
Okay.
It's good. Good? One more? 200. It's better?
That's it.
Okay. So this class, we are going to definitely, this is a public class. And we're going to have some properties. We need to have index, we need to have timestamp, previous hash, and we also need to have a field to store data. So let's do that. So make it that simple. Okay. So we need to have public. Let's make it that simple. And we need to have hash. And we need to have a previous hash.
So you have to have those specific terms.
That's just name convention. Easier for people to understand. And timestamp. And we also have data. So make it simple. So this is just a very simple data class. Everybody can do it. After we have this, then we need to also put them together as a blockchain. So we need to have a class called blockchain. Okay, so we have a blockchain because we want to store a bunch of blocks in this blockchain, so we need to have something to store them. Let's just create a list to contain them. Okay, so that's my blockchain, but it's right now doing nothing. Then we need to go back to this block class because we need to, first of all, allow us to generate a Genesis block. So that Genesis block will initialize some of the fields, such as timestamp and the hash. Okay, we need to have algorithm to generate a hash. So we need to have a hash algorithm we call calculate hash. The algorithm will use SHA-256 to do the hash calculation. So we need to include that. I think it should be a default. Let me look at this piece of, okay. So let me add the namespace into here. 256. After we have that, we're going to create this hash. So if you remember how to create hash, you should have no problem to do that. we want to consider everything here. That means we want to consider the index, we want to consider the timestamp, we want to consider the data to generate this hash. After we have that, one more thing. After we have that, we can get our hash. And we want to return this generated hash. But of course, we want to return into return as a string. So I need to convert into a base 64, not a char array base 64 string. So we have our, we need to return the string, so it's not this. So we have our calculate hash function. After we have this, then let's go back to blockchain. And we need to create a, we need to have a constructor here to set up something first. Inside the constructor, we are going to initialize our chain. The most important thing is to initialize our block list. And also we need to add the Genesis block. That's the first block. Okay. And we need to have this initialize chain function. And we need fix the spelling later. So this one will basically just set up our block, basically new list of blocks. Okay, and we need to have the function to add a Genesis block. And the Genesis block is basically our first block. So we'll have our first block. And I need to go back to our block class, add a constructor. So you will allow me to pass in the timestamp, previous hash, and the data. So use those to initialize the class level property. And the data. Okay, so let's go back to here, and then we can start. Okay. Oh. Okay. Yep. Thank you. All right. Yeah, this is outside. Yep. Thank you. So back to here, we are going to create a so we are going to use the current datetime, and because it's Genesis, so you don't have previous hash, and the data, it's also empty JSON data. After you have that, you can add that into the list, block list. Okay, so let's fix this setting. Okay, so by doing this, we have our initial blockchain setup, but basically this is doing nothing, right? This is just the first block, Genesis block, and we need to allow our blockchain to continue to add new blocks. So because we are building a chain, right? Always have a start point. Then the start point need to be the first block. So that's why we added that Genesis block. Yeah. I'm going to set index because this is first block, Genesis block. So index will be 0. But the rest of the block will be based on the previous index plus 1. Yeah. So that's another thing I need to go back to fix in here. Actually, I will default this to 0. Yeah. Okay. Then after we did this, let's go back to add more things into this blockchain class. I try to spend a little bit more time on this one, but after this one, I'll move much faster because this will give you a basic concept, right? When you think about a blockchain, you just struggling. What is it? But this will give you much concrete example. How does it look like? So, like I said, I need to add additional method to add the generic block. So, in here, okay. So I add a generic block. I'm going to, before I do that, I need to have a method to get the latest block from my chain. So I'm going to have a helper method to do that for me. So it's very simple. Then so it's just to get the last one. Blocks. It's not block. Okay. So after we have that, we'll get the latest block. And we will use that. Somebody asked me about the index, right? So I'm going to use the latest block index plus 1. So that's a place to set up this index. And for new block, I'm going to use my previous block's hash to set the previous hash, and I'm going to calculate the hash for the new block. Use the calculate hash method. After that, I'm going to add it into my chain. So this will be more stuff into here. After I have this, I can start to building this blockchain right now. Basically, I'm going to create a blockchain here. This is my P blockchain, and I would say P coin. Even we said we don't want to talk about the Bitcoin, right? I just want to use this example because, yes, just want to simplify. Yes, this is Philly coin. Or let me just Philly coin. So we'll become rich if we can launch this to an ICO. Okay, so after this, I can start to add in blocks. So I will create a new block, and again, I will set the timestamp. I will say this is about I'm lending money to my hash. And receiver. Yeah. Okay, so million Philly coin, probably 1,000. Yes, you can get whatever number you want. Let me just copy this. And let me make. So because I gave him 1,000, right? He need to return back. He need to return back to me. So he returns back me 500 and another 500. Okay, so we can run this, but before I run this, I want to add a way to output the blockchain. So you can see the structure of our blockchain. So I need to add a NuGet package. It's called Newton. Let me see. Here. Yeah. Fast. Yeah. This is one. I want to add into my solution. So after I have this, I can go back to here to output the result. import the namespace into here. Serialize a object into JSON. And format this to make this look good. Okay. So after this, let's run it. Oh, let me add something else. That's okay. Okay, too quick. You didn't say anything, right? Let me try to pause this. After I did this, let me run this. You may be able to. This is our first blockchain. So you can see.
That's worth hundreds of rupees.
It's very simple. We start with this kind of concept, right? You basically just need a data structure to store data. And you need to have the genesis as the initial block, and you can continue to add blocks. The Bitcoin, it's exactly the same thing.
You're not doing any code to check and make sure.
Exactly. Exactly.
So
My block is not safe at all. Anybody?
I've heard that.
Exactly. So, like I said, right, I give my hash 1,000 coin, and he will return back me 500 once and twice, right? But how about let me do something bad? Instead of 1,000, let me change the data since there is a 10,000. So he owe me more. So I can do that by simply, let me stop this. Change our data structure. So for the first one, we know the first block is genesis, but the second one is the one stores data. So I want to change the data here. Let me go back. Okay. I only want to copy this. It's called transaction. So everybody knows you can also call this public ledger, right? So public ledger records how much money you give to somebody, how much money you receive back from somebody, right? So I would say he owed me, instead of 1,000 coin, he owed me 10,000 coin. He owed me a lot of coin. And if we don't have any kind of verification, that become situation. So we cannot let this happen. This is not secure. So we need to add some kind of verification. So let's go back to the block. Let's add a new method called isValid. The way to verify this is just to compare, because you can see, if I go back to this one, we have each block stores the hash of the previous block, right? So we can verify if first of all, if I change the data, the hash will be still same or not, right? Because every time you change the data, the hash is different, right? And also, if you change the previous block, the previous hash is different. So that's the way we're going to verify this. So let's add more logic into here. Okay. So it will be just loop through this chain. So we have a lot of blocks here. Oh, this is not right place. Actually, it's a place in the blockchain. So in our blockchain, we says we're going to loop through all the blocks. And we need to get to the current block. From this. Yeah. So after we get a current block, we also need to, we can verify if the current block is valid or not. We just use current blocks hash to compare. We were going to recalculate this hash to compare with that. So if they are not the same, that means somebody already changed it. Okay, so this is the first thing we need to check. But the second thing is, like I said, we need to compare this with the previous block. So we need to also get the previous block. And also compare them. So if they are not the same, then it's changed. Then let's use this to verify our chain. So we're going to output this. And we're going to just call this. Okay, so let's run this. Both, because we changed the data, right? Then you will say, how about after I change the data, let me recalculate. I'm a smart guy, right? Let's do that. First of all, after I change the data, if you look at my code, the calculate hash will get yeah. Yes, that's why I start with 1. Yeah. It does have the previous hash, and it's a squad of just yeah, of course. You want to set a break? Give me 3 days. I'll put all the comments in here. So let's run this in debug mode, okay? So we start with 1, right? The reason we want to start with 1 because we know all the chains start with the genesis block, right? So we want to verify the first data block. So we got the first data block, and we got the previous block, that's genesis block. Then the first verification we are doing is to say, okay, the current block is changed or not, by compare the hash value of the current block with the recalculated hash value. So if they are not the same, that means it's changed. So we actually failed this validation because its data is changed, but the hash haven't been recalculated. I know you are asking about the previous hash, right? So that's something I'm going to show you next because I need to recalculate the hash. You will pass the first validation, but you will fail on the second validation. So let me go back to the code. Like I said, I'm a smart guy, right? So after I change the data, I need to recalculate this. So let me do this. Then, of course, we need to verify this again. Yes, this one, of course. Okay, so we have number 1, number 2, number 3, right? Okay, so let's run this first. Let me turn off the breakpoint. Let's see the result first. First one passed before I change the data, right? Second one failed. Hold on. I will check. Oh, this one, right? Sorry about that. Let me fix the font first. Properties. The font. Is this bigger? Good. Okay. So the second one. this is Windows, by the way. Okay. So this second one failed. Let's go back. Okay, so second one failed, right? It's because after we changed data, it's already incorrect. But third one still failed. We changed data and we recalculate hash. Why still failed? That's because we have a second layer validation. It's to compare the current block, the previous hash, with previous block's hash, right? So that's why it failed again. You want me to step through the code? Do you understand the comparison? Yeah. We have it's not a starting balance. It's because you have a data structure linked list, right? You must have a start point. Yeah, that's called genesis block. Okay, I know your point. Yeah. That's why I need to do the coding right in front of you, so you can catch my bug. Yeah. Yeah, that's okay. Maybe after this, I'll start to copy the code. Yeah, so it'll be faster. Okay, so I think let me go back here. I think you guys talk about this, right? So suppose I should to calculate the hash for the Genesis. Yep, that's good. Run again. So Genesis has hash. That's your question?
So if somebody does an ICO, is it normal to have the data always?
Always.
It doesn't say this block is
That's a good question. Yeah, that's a good question. Yeah. Yeah, Genesis doesn't matter. Everybody understand we have a linked list. We need to have a start point, right? That's okay. Yeah. Okay. So I need to speed up this. Okay. So we talked about this. We talked about the auto verify, and I'm going to stop at here, and I'm going to say instead of. That's a good question. Let me show you. So let me close this up. I'm going to show the code I wrote before this presentation, because I can say it's a little bit time consuming to do this coding here, and easy to make mistakes. So that's a good question. So I changed one of my block, right? And I recalculate hash of that block. Now you may say, you guys are also smart guys. Instead of only recalculate one block, hash of the one block, I'm going to recalculate hash of every single block. So that's what I was doing here. So I just keep recalculate hash for all of them. What's the result? Let's run this. So it's very, you'll be surprised. The end result, the chain is valid. After you change every single block and recalculate the hash of every single block, the chain is valid now. You can see there's a problem. So how to stop this? The way to stop this is by doing proof of work. Proof of work, what's proof of work? My hash already gave you some business side definition. The technical side definition means you need to do some work to prove it. That's something correct. How to do work? We are using computer to talk to computer. That means we need to make our CPU running crazy for several hours to come up with something to prove that's correct. So that's a concept. So let me move on to my second demo, because I don't think I have much time. So let me directly talk about the changes for the correct. You cannot change anything in there. You cannot change. It's immutable. But the data structure doesn't prevent you to change it. That means you still can change it. The lab work will stop you to change it, because each of the node will verify data from other node. So that's from lab work level. But you have the application running on your local. You can change the code. You can change the data. but that will not be proved by other people. So that's called consensus. So I talk about, if you look at this diagram, right, we already have the blockchain. We have 4 blocks here. We have Genesis block. We have block 1, 2, 3. So I'm going to add a difficulty, and I'm going to add a length. Why do I need to do that? It's because I need to do proof of work. So let me directly jump to the code. The block is almost same, like I said, except there is a new property called length. Why do I need that? I will talk about this later. I'm going to talk about the chain first. So for the chain, I add a new property called difficulty, and I set it as 2. So you know I'm going to calculate hash, right, for every single block. But for my first demo, I will just say, just give me a hash. I don't care what kind of hash you can give to me. But if in my second demo, I have some requirement. You give me a hash, needs to have some leading zeros. So based on my difficulty definition, I need to have 2 leading zeros. Sorry about that. Okay. So let me go back to the block class. You remember my calculate hash function, right? It's still same, but I add a new method called mine and pass in the difficulty. So the mine basically will call, yeah, I can find it. The mine will have a loop and will call the calculate hash. The loop will get a hash, but I need to say the hash has leading 0 match with difficulty or not. If matches, that's the hash I'm looking for. You may think this is simple, easy. Let me run this. So right now, my difficulty is 2. And my code is almost same. Okay, so it's pretty fast, right? I got everything back. How about it? Let me increase this. Let me plug my power adapter first. I don't know where is it. Oh, here. Found it. Okay, cool. So let's go back. Let me change this. How about let me change this to 3? I need to have 3 leading 0 for the hash code. Let me run this. I'm waiting, I'm waiting, I'm waiting. Why? Because it's more difficult to find this hash. That's just 3 zeros. And I have latest model MacBook Pro. If I change it to even 5, 10, you can see how difficult it will be. This is called proof of work. Your computer need to do some work to come up with that hash code. And use that hash, put it into your block, and add that block into the chain. that's to slow down the process of generate block. Why need to slow down? I'll explain that later. But you can see it's so difficult to generate. So let's just stop there. So let me go back to 2. So if I go back to 2, you can see the result immediately. Okay, so it's back to normal, right? But this didn't answer the question about if somebody changed every single block in the chain, how do you stop that? The concept is when the difficulty is high enough, no matter what, it's consent, right? On average, you could take 7 minutes to 10 minutes to figure out a hash. After you have the hash, then you can add a block. So because that, no matter how good your computer is, you still need to take the average time. The legwork, we would think, in general, everybody's good. They are good players, right? There are some bad guys, not everybody. Then you're competing with each other. When there is a new data come in, want to add into the block, everybody try to come up with the hash, add the block into the chain. Good guys will take 10 minutes. Bad guys also need to take 10 minutes. But because the bad guy need to change something and recalculate every single block after that. So you can see how much time the bad guy need to take. But the other thing about the blockchain is when there's some conflicts, they will look at whose chain is the longest one. Because good guy will keep going. Bad guy will go back to calculate something, then continue. So the bad guy always slower than the good guy. So that's how they stop this. It sounds a little bit complicated, but it's not. Because the blockchain doesn't have a central authority, right? You don't have somebody to ask for. So they are using this kind of, that's why you need to use that much computing power, because everybody's rushed to calculate this. Then the next question is, why everybody want to do this? In order to generate this hash, look at my laptop, it's not that bad, but I need to keep that running probably for several hours to get that hash. Why so many people just connect their computer into the network and do this for you for free? Why? Actually, it's not for free. There is a reward. So that's the next demo I want to show you. Because we talk about this blockchain I created is to build a daily coin doing transactions. So I did a little bit refactor. Before, I'm storing JSON data into it, right? So I add a new class called transactions, just like structure the data a little bit better. So I have from address to address and amount. Okay. Instead of put the string there, I'll create a new transaction and add into the chain. So let's look at the block. What kind of change we had here? Instead of have a data property, so we have iList transactions here to store transactions. And one misunderstanding for the blockchain is people feel like one block can only store one piece of data, one transaction. That's not right. All the transactions will add into a pending transaction list. And everybody's busy on trying to come up with some kind of hash. And so they will actually add all the pending transactions together and try to calculate the hash. As soon as they find a hash, they will add all those pending transactions into a block. So that's why I'm not having one single property called transaction. I have a list transactions. The result thing is same in this block class. So let's take a look at the blockchain class. us. Again, it's just minor change, but you can say I have a new property called reward. For people contribute their computing power to do this kind of work for us, for the network, they will get a reward. So whenever I'm going to add a block, so let's go to this create transaction. So create transaction basically just add a transaction into pending transactions list into the queue. And when we call the process pending transactions, we start to grab all the transactions in the queue and try to come up with their hash code. So after we get that, then we'll be able to add a new block. Then after this, we'll create an additional transaction. It's a reward transaction. So whoever figured this out, they can create a transaction for himself and put in reward here and put into the queue. So that's why everybody try to do this. Because as soon as you come up with this hash, you can reward yourself. And especially right now, Bitcoin price is going like crazy. A lot of people become rich. So let's run this. Let me see anything else here. So the resource stuff, I think it's same, except I also add a method to calculate the balance. Let's go back to program. Before I run this, let me go back to program. So it's almost same, right? So I'm going to create a Philip coin, and I'm going to create a transaction. So I give my hash 10 coin, and after that, I will use NetBuild to help me to process this. Because he processes, he got a reward. My hash return me back 5 coin, and return me back another 5 coin, and I'll NetBuild to process this. Okay, so let's run this. Can you see it, or it's too small? Okay. Because I give my hash 10 coin and he gave me back, eventually we both are 0, right? But Bill, he got a reward because he's working on this, provide his computing power to do this. Nothing is free. Yeah. So let's look at the chain. The first block is Genesis block, right? Index 0. So there's nothing here. Then start from second block, you can see we have transaction here. This is second block. And the launch, I forgot to talk about the launch, sorry about that. I talk about we need to find the hash code, and that has leading zeros, right? Difficulty. So you have data, you have data, you have index, right? And if you try to come up with hash code, unfortunately, the hash code is always same because everything is same. Hash code should be same. So the purpose of launch is we want to come up with a different hash code. So let me go back to the code very quick. So you can see I increase the length. And length also be involved into this algorithm to give me the hash code. That's the only way to change your hash code. If you don't have something change, you'll get exactly the same hash code. So by doing this, you'll keep getting a different hash code until you find a hash has difficulty meets your requirement. So I just want to expand this. Let me go back to the current application. Okay, so that's the first block, right? Only have one transaction. But look at the second block. My hash returned me back 5 coin. And because and return back another 5 points. Let me go back here. Go back to the code first. So you may get confused. Yes, there is the moment of running process pending transaction is very important. You can see those two transactions are in the pending transaction queue, right? But you may ask, why there is a extra transaction here? That's for Bill, because he did the work, but he did the work previously. Because the transaction after done the work, then will be added into queue. So that will be processed next time. So that's why it show up at the next block. So there are 3 transactions. So his reward for the second work haven't been processed yet. So it's not in any block. So that explains to you how the reward works. Because the reward is in place, a lot of people want to connect their computer to the blockchain network and to give away their computing power. They can earn coin. Exactly, they can earn coin by doing this. Any questions? Makes sense? I tried, but right now it's very difficult, very, very difficult. Because you need to have a specialized computer. The difficulty is so high. Yes, exactly. Then that's a good question I have.
I can answer that. So this is just a basic fundament, right? When you create your own blockchain, you create those certain rules. So you allocate a certain amount of coins just for this. If you look at all the coins, you will see in coins, then you will say 50% of coins will go to turn into, say, so much billion of reward. Then stay in your system. Those reward points convert into real coin that you get paid from whatever gets. It's like think of it like game. And those coins you earn, they are traded somewhere on the real trading platform where you can sell and they get paid.
What is that up?
There's a big system in the background which only certain people have access to. So if you're just doing second form, all data is public. And all the most of this. Yeah, so most of these, all these cryptocurrencies, all data is public, right? So how many points given, how many who earn what, how many spent. So you can just query all that through APIs and all that, but it's up there. Some have an API, some you have to write the code, some you have to use projects, some don't even have it. So it's like right now it's very new space. That's why Bitcoin is probably the most advanced coin. There's a lot more out there, but then they're updating every like new, because community people are coming, like somebody say, you know what, we need a reporting API, and somebody go to put the reporting API and get all the data from there and basically show you. It's every project is different. So yeah. You have to know what format data is stored. So you have to download the project, learn the whole project. It's an open source project, right? So you have to literally dig through the whole thing. And then yeah, you can build whatever you want, really, yeah.
Yeah, that's something I'm going to demo next.
Yeah.
Yes. So I have a lot of demos. I start with a basic chain, and move on to the transaction, move on to reward, right? I talk about the proof of work.
I get a reward for reminding you have 15 minutes.
Okay, that's enough. I'm almost over.
In fact, 10 minutes because he's going to give out prizes. So
Okay, so that's
we
enough.
will yank you after 10 minutes.
Then the last demo I want to give to you is about how everything works on the network environment, right? Everything is running on my computer, right? So even I talk about it, so many concepts, but how they different nodes or different computers talk to each other. There are many network protocols, right? So you can use whatever protocol to talk to each other. But the example I want to show you is I'm going to have a client and a server, and they are going to use WebSocket to talk to each other. So let me run the demo first. This represents me. So I start a node at this address, and this is my name. I'm going to start the second node. At port 6002. Okay. Let's look at the first one. Because I just started this, only has Genesis block in there, right? Let me add a transaction to it. I want to give money to my hash. And 100 coin. Okay, so let's look at our blockchain again. On top of the Genesis, we also has, actually this is Genesis. So it has one more block in here, right? Somebody did this work, supposed to get a reward, but then will wait until next process. That means will be in next block. Okay. Then in my second node, because I only have one computer, I want to connect to the first node. And I will give the address of the first node. Can you see it? It's small, very small. Are you sure you can see it? Okay. Okay. I connect to there. Let me see. Yes. Let me make sure the address is correct. 6. The address in there. Okay. It's correct, right? Okay. I don't think the address is correct. Let me try again. This is no good. Yeah, it's crashes. Let me run this one more time. If it doesn't work, then we can run this example. I think probably because I already connected there, somehow didn't connect correctly. Yeah, I can see it didn't connect correctly. Yeah, suppose if you connect correctly, right? I should get a message. Yeah, So I don't think I can do this thing. Maybe, but I can explain to you what's going on. So after my one node connect to a second node, I mean the second node connect to the first node, I will retrieve the transaction or the block from the first node. And start from there, whoever add a new block will broadcast to other block, other nodes. So all other nodes will get that block. And they can sync the information with each other. And because it's peer-to-peer, and they will, based on the consensus, they will do verification. They will see whose chain is the longest one. That will be the valid chain. And go use that as a base to add future blocks. So that's the network, how the network. With that, I think I cover all the demos. If you have questions, you can ask me and I'll ask Mahesh. Yes, all my code is on the GitHub. Let me.
We don't have a place to store code. He puts it on his own GitHub.
Oh, okay. So it's on my GitHub.
Already there.
Yeah. I'll probably find it and I'll provide to you. Okay. Yeah. It's in my GitHub. So
The cost to download this code is only 2 Bitcoins.
any other questions?
So next code camp, there will be no prizes, just coins.
When you get it, the block, you need to verify first, right? If it's correct, yes, you can add it. It actually not only broadcasts one block, it broadcasts almost the entire chain. Depends on your algorithm. So you're not only, because you don't know who will receive this. So we'll keep broadcast the entire chain to all the nodes in the network. Not really. Another concept I actually didn't go into is there are multiple chains. There is a blockchain, there are transaction chain. So they will decide the chain they need to broadcast. And actually you can.
Your code, it just downloads everything or the change is made. Same thing applies here. Here data is also, you think of that as a code. So any changes made on his node, you sync it, it's going to download all that on your machine again. So pretty much you'll have exactly same copy what he has, or anything is new updated. Every node will have same copy. So you don't do manually anything yourself. The project manages this whole syncing process. Any more questions?
I think this was an exceptional introduction. How many liked it? How many want to write their own blockchain? You'll learn eventually. There's a question from the studio audience out on Mixer.
Yeah, I got a question. What are good resources for learning more about blockchain as a beginner?
Good resources for learning about blockchain as a beginner.
You can go. So it depends on really what your expertise is. I would recommend if you are a C++ developer, you have different projects. There's no one resource right now. So you have to find, for example, if you're writing smart contracts, which we need to probably cover next session.
Yeah.
There's an Ethereum project is good for that. So some of these projects are designed for a specific purpose. Some are for financial. So it really depends on. and then you have to learn that project. Right now, there's some books out there on different projects, so that's where I would probably start. But on GitHub, you start with the GitHub. They have the basic written there, all the project download, how to start, and then each project has their own website. And that's the best way to start because these are open source. Documentation is pretty solid on that project.
Yeah.
Is that it, Chris? All right. Well, you all behaved splendidly. Thanks for coming. You are all now to take out a dollar bill. And Mahesh has a prize.